In this section, we're going to look at the rise of self-supervision, or in short, how AI learns on its own. So in earlier sections, we looked at what a language model is, and we looked at how do we train a large language model with vast amounts of data. And we talked about the smallest unit of the AI's learning model, which is a token. So now in this section, we're going to look at how AI can learn on its own. So when you type a sentence into a modern language model like ChatGPT, something really fascinating happens. It does not think like we do. It does not know what you mean. It just completes what we have started. So if you have typed in a question saying, "Who am I?" it looks at it one token at a time and takes a probabilistic guess at what could be the next word that should appear. The whole series of words that it predicts becomes an answer. And it's fascinating because just by predicting what the next token is, you actually feel like you are talking to an intelligent artificial being and it seems to respond to your questions. So that is why it is called generative AI. It generates what is most likely to come next. However, these completions are not facts. They are predictions based on patterns found in a vast ocean of text. So we trained this model with libraries of data, we trained it with encyclopedias, Wikipedia, lots of text that is available online, and now it can look at the patterns that it found in this vast amount of data we fed it, and it can predict what can be the best word that can come after whatever you have typed. In all probability, we typed a question saying, "Who am I?" and it's going to give the most probabilistic answer by predicting the next token. So the model's task is to decide what is the most probable next token given everything I have seen so far. That's what it does. Sometimes it is right, most of the times it's right, sometimes it could be wrong, and you need to be aware of that if you're a user of these large language models. So now let's look at a particular use of large language models. So far we looked at prediction, where it tries to predict the next token, but there is also another major use of it, which is classification. So given a pattern, it can try to classify what kind of a label has to be attached for this. So let's talk about email, for example. So the same mechanism can be used to look at a large amount of emails and bunch or cluster together a bunch of the emails with very similar content and give it a label called spam. So a human can say that, okay, these bunch of data that you just saw, which are all similar, that is actually spam. And anything else that does not fit into this bucket is not spam. So you have a classification engine which can basically look at your email headers and classify something as spam or not spam. It's the same mechanism. It's not different. So ultimately, generation and classification are two sides of the same coin. Prediction. It's trying to predict which label has to be applied for this particular set of data. So the beauty of this model lies in their adaptability. They can summarize, translate, complete, categorize, all of which utilize the same underlying principle. So now let's get into another area called supervised learning. What we just saw, where we asked the model to classify email as spam or not spam, is supervised learning. Why do I say that? Because we gave it a label. We said that, okay, all of these emails which start with this kind of cheesy headers, this is all spam. So based on that, now the model can identify a bunch of headers of emails which match what we just called as spam and call that as spam. Similarly, if you have a whole bunch of cat images, it can categorize them. If you give it a label saying all of this is a cat image, it knows that. Now imagine a human sitting and trying to look at all the clusters that the language model has created and then start labeling it. It's a very intensive effort. So in many ways, the early AI success was not limited by the algorithms, but rather by the human effort required for supervision and training. So if you look at credit card transactions, for example, some of them can be marked as fraud based on what the training data says or what the user says. So based on certain parameters, you can say, okay, this is a fraud transaction. So the next time the model looks at a transaction that matches a label called fraud, it knows that okay, this is a fraud transaction and this is a safe transaction. But it requires human effort. So it was a huge task. So around 2010, there was a shift in how we train models. We came to self-supervision. We, in the sense, the industry came up with an idea that what if a model could generate its own labels from the data it sees? The simplest example that I can talk about is if we have images which have labels below that. Let us say we have a bunch of photos on Facebook or Twitter somewhere, and people have tagged it saying, hey, this is a nice cat. Hey, this is a nice bridge. Oh, I know where this is. This is, let's say, a city called Delhi, right? So these are all labels, and people have just added it to the images. If we take these images, feed it to the language model, of course, it can start identifying bridges, cities, those things. It can also look for the text or the label that is attached to that. Now, suddenly, it's able to also figure out the label to be used with a certain cluster of images. So, all cat images, it knows that the label is cat. And there was no human involved. Humans did that on social media, right? That is a simple example. But now let's take it a little more further. What about learning language on its own? Let's take an example of a sentence like, I love street food. And that's a simple example, but as a human, we know that, okay, this sentence is about food. I love street food. So, food is the label or tag or the context. So, if you feed it tons and tons of text which talk about how I love street food, oh, there is street food here and there is a certain dish that I like. So, a lot of things around street food. Now, the model can categorize these sentences with a common word or a label that is occurring everywhere in this context and call it as food. So next time it sees something that is related to this sentence, it knows the label that needs to be applied is food because it was common. It was there everywhere. So it picked up the label from the content itself. So the missing word becomes its own label. So if we have a sentence like I love street food and we remove the word food from that, the missing word becomes its own label. So if you do this billions of times across books, articles, entire internet, the model begins to learn about grammar, meaning, and even context, all without human annotation. So this process of learning is known as self-supervised learning, where the model teaches itself by reconstructing parts of its own input. So we talked about this particular example where I said, I love street food. And if you remove the word food from that, which is a label that it has identified, which is something that frequently appears, so now it can test itself and say that, okay, if I have a sentence like this, the best fit for this is the word food. And then if we get into the printed universe, we have tons and tons of text printed. We have articles, blogs, books, forums, which all post a clue to the grand puzzle of human expression. So humans have written a lot. We have everything all the way from scriptures and Vedas, all the way to modern AI books and content, videos. There's so many things. So if you feed all of this into the language model, what happens is it starts to identify repeating patterns, it starts labeling them, it starts to build rules, grammar, it basically starts learning things. So we as humans, we absorb patterns from speech. We look at books, we read, we mentally categorize something, we put a label, we observe. So this developing understanding from repetition and context rather than an explicit instruction is fundamental for self-supervision. And in this sense, self-supervision mirrors human learning. It's not different. Both grow through exposure rather than memorization. So why does this matter? So this self-supervision concept, though very interesting, why does it matter? Self-supervision unlocked the scale that modern AI needed. It removed the bottleneck of labeled data and allowed models to learn from the collective text of humanity. So this is what made training systems like GPT, Palm, Gemini possible. Models with hundreds of billions of parameters absorbing patterns from trillions of words, and we have something that feels intelligent like ChatGPT or Gemini. So later on we'll see how this broad general knowledge can be refined through fine-tuning or post-training, where a general model becomes a very helpful assistant, a coder, or a domain-specific expert. However, at its heart, every language model remains what it began as, a completion machine. It predicts the next token, it learns from patterns, discovers meaning in the flow of words. So, welcome back to the next section and we'll go into all these details. Thank you for watching.